Thank you for stopping by helpyourmath.com. In this video, we're going to look at graphing piecewise functions, specifically when the pieces are pieces of linear equations. So if you're looking at other ones that have absolute value or quadratic, this might help get you started, but we're not going to look at any examples of those. So a piecewise function is a function in which there's different pieces of the graph. So in this case, we have two pieces. We have the piece for when the domain is less than 0, and we have the piece for when the domain is bigger than or equal to 0. So the graph is going to be split into two separate pieces. Now this graph is a little strange because so when x is less than 0, we just have an output of 3. That indicates this is a piece of a horizontal line, because that horizontal lines, if we were to write this piece all by itself, would be g of x equals 3, which is just a horizontal line. In order to graph any linear equation, you need a minimum of 2 points, and so that's what we're going to base all of our graphs on. So we always want to use the endpoints or starting points. I definitely want to use 0. The thing about using 0 in this piece is that 0 isn't actually included. So when we graph the point, the endpoint, we use an open circle to indicate 0 is not actually included. So I can't say g of 0 because that's factually incorrect. So what I do is I just do an open circle, and I'm going to put 0 inside of it. And that's how I'm going to remember that it's an open circle and that I'm plugging it into a piece that it actually doesn't belong in. So this would be the point 0, 3. So I graph 0, 3, and again I use an open circle to say this is where the point is, but we're not actually including it in this piece. And then I need one more point from this piece. Every other point on this piece, in this piece, will actually be included, so we'll use a closed circle for any other point you choose. Whether you choose to plug in -1, -2, -3, it doesn't matter, as long as x is less than 0. So we could plug in g of -4, let's say, and when we plug in -4, since there's nowhere to plug it into, we're going to end up with 3. So -4, 3. Now we have 2 points on this line. So again, our line segment. So this line segment is a horizontal line going only to the left, right? Because we stop when x is 0. For the second piece, we just have -2. So this piece looks like g of x equals -2, which is a horizontal line at -2. However, we only want to include the piece that this piece entails. So this says x has to be greater than or equal to 0. So the 2 points, I'm going to use g of 0, and I get to say g of 0 because 0 is included thanks to the greater than or equal to. And it'd be, when we plug in and we get 2. So it would be 0, 2. Sorry, 0, -2. And we use just a closed circle there. And then we can plug in any other point so long as x is bigger than 0. So maybe we plug in 6 because 6 is on my graph. We're going to get -2 when we plug in 6. So 6, -2 would be here. So as I mentioned, this one's also a piece of a horizontal line. And this is what the graph of g would look like. Our next example, we also have g of x. This time we have two pieces where the separation point is at, well, one piece ends at -2 and the next piece starts at 2. So we'll have a little break in the graph, which is fine, it doesn't matter. But we know that the values between -2 and 2 are not part of the domain of this graph. So for our top piece, we do get to plug in -2. It does belong to that piece. We'll say g of -2 equals -2 plus 4, which is 2. So we have the point -2, 2 is 1 point on the top piece. Now we need one more piece. We want to choose any number so long as it's less than -2. So we could choose, let's say -5. Hopefully -5 appears on our graph. That would be -5 plus 4, which would be -1. So that'd be -5, -1. -2, 2, it is included, so we get to use a closed circle. -5, -1 is down here. And remember, the graph ends at -2 and it only goes to the left, so it's going to go this way. Now for our second piece, we have 1/2 x minus 3 when x is bigger than 2. So we do want to use 2, but 2, remember, is not part of this piece because there's no or equal to underneath. So I can't say g of 2, I'm just going to say 2 with an open circle. And when I plug in, I get 1/2 times 2 minus 3. That's 1 minus 3, which is -2. So this would be the point 2, -2. And remember, it's an open circle. We need one more point of this piece, and we want to make sure whatever we plug in, we're going to have to take half of. So I would suggest choosing an even number. Let's use 6. G of 6 would be 1/2 times 6 minus 3. Half of 6 is 3, and 3 minus 3 is 0. Oh, we found an intercept. So that would be 6, 0. So when we go to graph this, 2, -2 will be an open circle, and 6, 0 would just be that kind of regular point. And remember, the only point that's not included is that endpoint. Every other point is included on the graph. So we do a closed circle at 6. Now, instead of actually using a second point, I could have also used the fact that we have a slope of this. Now, because this is the one where x is bigger than 2, we would have to go to the right no matter what. And that would tell us go up 1 over 2. So there should be a point here, up 1 over 2, where we have that second point. So either strategy is fine. If you're going to use the slope, just be careful, especially for the top one, the x plus 4, because we can't go to the left. So if we started here, we couldn't go up 1 over 1 this way, because that point's not part of that piece. We would have to go to the left. And a slope of 1 over 1 is equivalent to negative 1 over negative 1. So we'd have to go down 1 to the left 1. We can try that on this one if we want. Except for the middle piece. So this time we have 3 pieces. We have when x is less than negative 3. We have when x is between negative 3 and 1. And then when x is bigger than 1. For the middle piece, you absolutely want to plug in the 2 endpoints. So we don't want to use the slope of the line to help us find any other points. But we can do that for the other 2. So for the top piece, we have g of x equals 2x when x is less than negative 3. Since negative 3 is not part of this piece, I'm just going to represent it this way. And that would be 2 times negative 3, which is negative 6. So we're going to have an open circle at negative 3, negative 6. Negative 3, negative 6 is right here. And then if we want, we can use the slope. The slope is 2, right? Because that's what's attached to x. That will be mx plus b. And so we cannot go up and to the right because we don't go to the right with this one, we only go to the left. So instead of positive 2 over positive 1, we would go down to negative 2, negative 1. Negative 2, negative 1. And of course, if you don't like that, you could always just plug in another point. You could use negative 4, negative 5, negative 6, whatever makes sense to you. For the middle piece, as I said, we have 2 endpoints. Those are the two points we want to use for this middle piece. Negative 3 is part of this piece, so we can say g of negative 3 equals 3 times negative 3 minus 2. That's negative 9 minus 2, which is negative 11. So we have negative 3, negative 11 is one endpoint. The other endpoint 1 is not part of this piece, so I can't say g of 1. I'm going to say 3 times 1 minus 2. That's 3 minus 2, which is 1. That would be 1, 1, and that's where I want to use an open circle. Okay, so negative 3, negative 11 is down here. And 1, 1 is right here, and I'm using an open circle. And hypothetically, we would use a straight edge. That's the best that I could do. That's what that piece would look like, a really steep piece. It does have a slope of 3, so that makes sense. And lastly, so for the last one, you can use either option. You can either say, well, we're given a slope, so I can use the slope once I know what that first point is. Or you can plug in 2 points. It doesn't matter. Since 1 is included here, we can say g of 1 is equal to negative 2 times 1 plus 4. That would be negative 2 plus 4, which is positive 2. So we can graph the point 1, 2 over 1 up 2. Oh, it's really close. And then from there, if we want, we can use the slope to find more points. Go down 2, we must go to the right. Down 2 and to the right. We cannot go to the left here because going to the left is not part of this piece. And we will probably want to make that a little bit straighter. Like this, down. Oh, I missed again. Oh, okay. Third's a charm. Let's see if I can get it. All right, good enough. And that's what that piece would look like. And of course, if you use a straight edge, these would turn out much nicer. Thanks for stopping by.